Hello students. In last lecture we have discussed about shift register and their types. Shift register are of four types: serial in, serial out, serial in, parallel out, parallel in, serial out, and parallel in, parallel out. So in last lecture we have discussed about serial in, serial out, and today we have to discuss serial in, parallel out. So serial in, parallel out means that we have to take inputs serially and outputs parallelly. Means इनपुट हम लेंगे बिट बाय बिट, पहले एक बिट फिर दूसरी फिर तीसरी, उसको शिफ्ट करते जाएंगे एंड आउटपुट्स हम लोग पैरेलली लेंगे एक साथ. सीरियल इन, पैरेलल आउट. सीरियल इनपुट ली एक और 4 आउटपुट्स होंगी आपके पास पैरेलल, और क्लॉक हमें अप्लाई करनी है. ये आपका इसका फ्लिप फ्लॉप को यूज़ करके हमने डिज़ाइन किया है सीरियल इन, पैरेलल आउट शिफ्ट रजिस्टर. In this we are using 4D flip-flops because we are designing 4-bit shift register. Input is applied only to first flip-flop and their output is shifted to second. Second output is shifted to third and third shifted to fourth. And this is a parallel output. So we have to take outputs parallelly also. तो हमने outputs को एक साथ ले रखा है. This is similar to serial in, serial out shift register, but the only difference is that output is also taken as parallel. Now the data used is 1011 and you can take any 4-bit value, 4-bit data. At starting we know that the output of shift register must be 0, as we have studied in flip-flops. So initially at 0 clock, the data is 0, 0, 0, 0 in the shift registers. So at first clock pulse, we have to enter this data by starting from LSB, then move towards MSB. At first clock pulse, this LSB value bit 1 is to be entered on the first, and then 0 is shifted to next 0 is shifted to next, and so on. And at second, next one is to be entered, this one is shifted to next bit, 0 is shifted to next, and this 0 is shifted to next. Third bit 0 एंटर कराएंगे, 1 आगे शिफ्ट होगा, 1 is shifted to next, and so on. And at the fourth bit, our MSB, that is 1, is entered into first bit. The 0 is shifted to second, 1 is shifted to third, and 1 is shifted to fourth bit. So at fourth clock pulse, the data in our shift register is 1011. This is serial data input, means data is entered bit by bit. And now this is a parallel out shift register. So we have to take these 4 bits as outputs at the same time. So it is called parallel output. This is also shown as in this truth table. It's clock, its outputs QA, QB, QC, QD. Initial clock, outputs at 0, 0, 0, 0, and at first clock this data 1 is to be entered and 0 is shifted to next. Then at next clock second, this 1 is to be entered and this 1 is shifted to next. At third clock 0 is to be entered at the first place and this 1 is shifted to next. At fourth clock, this 1 MSB bit is to be entered at first, this 0 is shifted to second place, 1 is shifted to third, and this 1 is shifted to fourth. So the data is entered serially, and then this data is taken at output parallelly, means all the bits are taken at the same time at the output. फोर्थ क्लॉक पे जो हमारा 1011 आपका डेटा इनपुट हो गया था, अब वही आपका एज अ पैरेलल आउटपुट हमें उसी टाइम रिसीव हो गया. दिस इज सीरियल इन, पैरेलल आउट शिफ्ट रजिस्टर. Now next shift register is parallel in serial out shift register. Parallel in serial out. Parallel in means the inputs are taken parallelly, means all the 4 bits of the input are taken at the same time and output is serially. Now input is parallelly and output is serially. So taken output bit by bit, means 1 bit at a time. On each clock we get 1 bit at the output. So clock is applied, parallel inputs, 4-bit inputs and single output. In this, one control signal is used, that is shift/load. Shift/load bar. Load पे bar है. That means out of these 2 functions, one function can be performed at a time. Shift is active high and load is active low, means shift will work at 1 and load will work at 0. When this signal is 0, then load will work, and when the signal is 1, then shift operation will performed. Load means parallel input, means input is applied at the same time for all the bits, that is loading of data. And shifting means we get serial output 1 by 1. So we have to shift data from first to second, second to third and third to fourth. So this is the flip-flop. D flip-flop is used. 4 D flip-flops are used in this shift register. In this, clock is applied to all the flip-flops at the same time. The 4-bit input is to be applied. MSB applied to the first flip-flop. This control signal is used shift/load. This diagram consists of, there are using 6 AND gates, 3 OR gates. It is a combination of 2 AND gate and 1 OR gate. 3 pairs are used. And we have numbering these gates N1, N2 and N3, N4, N5 and N6. The output of flip-flop is connected to first gate, that means N1, N2 and N3. QA is connected to N1, QB is connected to N2 and QC is connected to N3. And the second input of these gates are connected to this shift/load. Similarly, for N4, N5 and N6 gate, there one input is connected to this shift/load control signal with its complement by using NOT gate. N4, N5 and N6, one input of all these gates are connected to this. And the second input of all these are connected to input data D0, D1, D2. And D3 is connected to the input of first flip-flop. This is for parallel data inputs. And for serial output, this QA is connected to N1. And through the output of this N1 gate, it becomes the input of OR gate. And through this, it will be transferred to second flip-flop. Then on application of clock, this input becomes the output for second and so on. So in this way, data is shifted from first to second. Okay. So this is our parallel in serial out shift register. For parallel in, this signal must be 0. That means from after this NOT gate is used, so it becomes 1, and here 0 is going to all the gates, applied to all the gates. So this one is applied to N4, N5, N6. That means these gates are active. And this 0 is applied to N1, N2 and N3. So these gates are not active. These gates are not working. Because in case of AND gate, if any of the input is 0, then output must be 0. So the input of these gates N4, N5, N6 which are active, their inputs decides their output. If their input is 0, then its output is also 0. And if its input is 1, then output is also 1. Which also decides the output of OR gate, which becomes the input to D. If input is 1, then input to D is also 1. And if this input for data is 0, then input to data is D flip-flop is 0. And for serial shifting, this signal, control signal has to be 1. So on this 0 is applied and it becomes 1. Now N1, N2, N3 gates are active and N4, N5, N6 are not working, are not active. These are disabled. So output of QA is connected to N1, which is shifted to the input of next flip-flop. Because N1 is active, so its input is already 1 and the second input, that is QA. If QA is 1, then its output is 1. And at OR gate, 1 plus 0, it becomes 1. So input to next flip-flop is 1. And if QA is 0, then the output of AND gate N1 is 0. So output of OR gates is automatically 0. Means our output QA is shifted to input of next flip-flop. And similarly, QB is shifted to next input and QC is shifted to next input. So this becomes the serial output. So on applying clock, the inputs of these flip-flops becomes their output. So we can get serial data output bit by bit. This is our parallel in, serial out shift register. And next is parallel in, parallel out shift register. Parallel in, parallel out means all the inputs are applied at the same time and all the output bits are taken at the same time. Input is applied and the output is taken parallelly. So these are the 4-bit shift register. Input is applied to each flip-flop and their output is also taken. In this flip-flop, the output of one flip-flop is not connected to the input of other flip-flop. When input is connected to all flip-flops and then output is taken simultaneously. Means whatever input is applied to these inputs, on the application of clock pulse, these inputs must be taken as their outputs. So whatever input is applied, that output is taken at the same time. That is called parallel inputs and parallel outputs. These are our shift registers. Serial in, serial out, serial in, parallel out, parallel in, serial out, and parallel in, parallel out. Thank you.